this problem here. No, this one here. We're trying to figure out what's the probability that a majority of 7 people surveyed support the issue. And again, we decided that if 65% oppose it, that's going to be my Q. And little p is going to be 35%. So what I did yesterday was I calculated, see, we said if you're going to have the majority support the issue, I said, what's the probability of 4 being in support of the issue? You know, guys, probably I should have done this to start. I should have done this. Here, let me write it down. I should start by saying, let capital X be the number of people surveyed that support the issue. Right? I could have said that. And then, what could I do? Well, I could compute something, right? So yesterday we did all these computations. Let me show you another way that you could have done this. You could have said, well, let's compute the probability that X is 3. Let's do that. This will be a good example of how the formula works. So how do you do this? The probability that X is 3. What are you going to write down? Yes, 7 choose 3 is how you start. Whatever number you want X to equal, that's what goes in for X, right? Times, and then we're going to do 0.35 to what power? To the third power, that's right. And then we're going to do times, and we're going to do 0.65 to what power? To the fourth power. Because basically, these two exponents always have to add up to what? Yeah, whatever n is. N is the number of times you repeat the experiment. In this case, our experiment was, hey, we're going to, what's the experiment? Oh, we're going to call somebody. And just say, what are the two possibilities? They either support or they are opposed to the issue. Hey, by the way, some people might say this is not a good example for binomial. Because what else might happen when you call? They might say, hey, I don't know. Right? So then you have to decide what you do. Do you have a third category, or do you just ignore those people? I guess I'm saying we're ignoring that. But that, as soon as you allow a third category, it's not binomial. You guys understand that? Binomial is 2 categories, success or failure. They have to be complements of each other in a sense. So what does this work out to be? Well, we did it on the calculator yesterday. I'll also use the computer today. I should show you guys how to do it that way, because we can really make things a little easier here. So let's see. What we type in is, do you remember? Well, we need to type in, let's see, it was 7 choose 3, right? So we hit 7, and then, remember where the choose is? Math menu. Where do I go? Over to the probability menu, and then it's choice what? Choice 3. NCR. So math, and then that gives me 7 choose 3. Then you want to hit the right arrow key, because that gets you out of that little bottom. Okay? And now I want to type in, well, 0.35. And then for an exponent, you want this caret key above the divide. So we're doing 0.35 to the third power. And then the right arrow key. Oh boy, I don't know if that's going to work without my times sign, guys. I better go back and insert a times sign. I mean, if you didn't, you can be my guinea pig and let me know if it works. Let me insert a times sign. Okay, 7 choose 3 times 0.35 to the 3, and then times, and I need what else? 0.65 caret 4. And so I got 0.2679 if I round, okay? So I'll go back here, and I could write that that one, hey, that's even more likely than anything else we had, 0.2679. Actually, that kind of makes sense, right? If a majority of people oppose the issue, it's not very, you're going to get, right? You're probably not going to have a majority in favor. All right, so what I'd like to do next is I'd like to do the probability that x is 2, the probability that x is 1, and then we also need the probability that x is 0. I'd like to do each of those. But I promised today I would show you guys a shortcut that the calculator has. They have shortcuts, okay? And so let me show you how this works. You guys, when you have these calculators, they store a lot of these functions on there. So I think the way I do this, I hit, yeah, I know. Do you guys see what it says right above VARS in blue? Distribution, D-I-S-T-R is distribution. So I'm going to hit second distribution. And this is a very useful menu to know about. Now the one we want is so far down the list, it's actually quicker if you go up. Okay? Because if you go up, you'll go back to these. Do you see the one I want? See that choice A? Binomial PDF is what I'm interested in. Binomial PDF. And so I'm going to select that. I'll hit enter. Now, if you have an old calculator, it's not quite as nice as this one. And I'll show people with older calculators what to do in just a moment. But if you have a new calculator, like we do on the computer here, it's very simple. You just kind of put in what you want, right? So how many trials do we have? Well, for example, we had 7 trials. That's what n is. So I'll hit enter. Then it asks me for little p. Little p is a probability, right? What's our little p? Yeah, it's 35%, right? So we need to hit 0.35. 0.35. And I'll hit enter. And then it says x value. Well, for example, the one we just computed was 3, right? And then we're going to paste that in. Now, for those of you with older calculators, this is the command. You need to type that in. So after you say binomial PDF, it just comes up here with the open parentheses, and you had to know what to put where. So you have to put 7, comma, 0.35, comma, and 3. All right? And if you do that, you're going to get, well, if we hit enter, the same answer we just got, right? It's quite a bit faster. Yeah. And it's fast enough that what you guys can do here for the next couple minutes, I got to run out for just a second. I'd like you guys to complete the chart, if you wouldn't mind. And actually, if you want to take out homework questions, maybe my shortcut will help with the homework questions too, okay? So a couple minutes for you guys to complete the chart and take out homework questions, and then we'll start up again in just a minute. All right. I'll be right back. You have to be sure if you're going to use the shortcut that you're doing binomial PDF. I don't think I told you what PDF stands for, did I? It's not the kind of file that everyone opens up by Adobe. No, what PDF is, it actually stands for something. PDF stands for probability distribution function. Right? This is all about binomial distribution, and that when we say function, this will spit out the correct number for the binomial PDF. So we need binomial PDF. What would we need to put, guys? We would need to put, well, first they want to know how many trials. So that's going to be 7, comma, 0.35, comma, 2. And then close parentheses. Sarah, this is what you were asking me, right? Yeah. All right. So I need to get that in my calculator. Let me try it. Well, I already typed in binomial PDF for the case 3. So you know the fast way to do this, guys? I showed you before. Second, enter, right? Then I get it right back. But if not, you have to use the math menu to get there. And what's the only thing I have to change? Change that to a 2. Enter. 0.2985. So we've got here 0.2985, okay? Right? Did anyone get 1? Probability that x equals 1? You got 1848? Anyone else get that? A couple? Just 3 of us? All right. So I'll give us a little more time. And when you're done, guys, I want you to add up the 4 blue ones that we just found. I want you to add those up and tell me what it equals. All right? So that's the final little step here. I'm going to walk around. There's a couple people I didn't talk to yet, and then we'll come back up front. I still have to compute 2 more, guys. So I need the binomial PDF for 1, although someone told me, but let me do it anyways. Go here to the probability menu. No, wrong place. Where am I supposed to go? Second variables, distributions. That's right. This is the fast way to do it. So if you go to second variables and you go up, binomial PDF is here. Oops, went too far up. There it is. Binomial PDF. Number of trials 7. P is 35. The only thing I have to do is change the x value. So I want 1. And I'll paste that in. So I get 0.1848. Yeah, now I remember. Someone told me that. So this one is, the probability that x is 1 here is 0.1848. And the probability of x being 0. Actually, that's kind of interesting. If x is 0, that means nobody was in favor that you called. And that could happen, right? If you think about it, if 65% of the people are opposed, you say, what's the probability that everybody I call is opposed? That means the first one is opposed. What's the probability of that happening? What's the probability of someone being opposed if I call them? We just said that. Not 50. I told you guys how many people are opposed. How many people are opposed? What percent? 65%. So the probability is 0.65 times another 0.65 times another. The chances of everyone being opposed, you could say, is 0.65 to the 7th power. Why is that? Well, because what's the rest of it? The rest of it is 7 choose 0, but that's 1, times 0.35 to the 0, but what's anything to the 0 power? 1. So really, it's just 0.65 to the 7th, right? For that top one, did you guys get, let's just see, did you get 0.65 caret 7? Is this the same as the answer you guys got? Right? Almost 5%. It says 0.0490. So let me go ahead and write that down, that this one ends up being 0.0490. And so did anybody add these 4 probabilities up? What did you get? You got 80%. If you got 80%, then how do you answer the question? What's the probability of getting a majority? Well, if 80% chance that you're going to be between 0 and 3, then there's a 20% chance, and so the answer to our question, just like we worked out yesterday, is 20%. Now, a couple things about it. I get this comment about what I just did. Hey, Paul, that's no faster. That is not any faster than what we just did. Right? I mean, I had to do 4 computations either way. Okay? But now, here's where I can show you a little bit of speed improvement. Right? There's a command on the calculator called binom CDF. Now, what's the difference between PDF and CDF? CDF stands for cumulative distribution function. Actually, we had the word cumulative back when we studied chapter 2. Do you remember what cumulative tells you? What's that? Hard to explain. Here, I think when I show you guys this, though, you're going to like it. Ready? So let's go to the calculator. Remember how we did x equals 3? Let's do this. Could you please follow me to the calculator? Everybody hit second distributions again. So we're going to hit the blue key. Jared, you want to do this too? Hit the blue key on the computer there. Second. Okay. And then go here to where it says variables. And hit that. And now, okay, right here, second, and do you see the key in red? That's where we're going. Second, and then the key in red. That's the shortcut. It goes to the distribution menu. Everybody with me? Yeah, please, thank you, Sierra. If I go too fast, you guys have to stop me so we can all keep up, you know? It's like I always say, hey, am I a good bus driver? I can do my whole route, but if I don't have any passengers because I left them all behind, that doesn't do any good. Right? You got to stop for your passengers. All right, next stop. Here we go. Where do I go to find these things? Remember the fast way to do it? Yeah, go up, because there's a lot of different distribution functions. Some of them say PDF, and some of them say CDF. PDF is probability distribution function, but CDF means what? Cumulative, and I'm about to show you what that means. We're going to choose this choice B here, binomial CDF. So I choose it. Now, how many trials? 7 still. What does P equal for us? 0.35. Now, you guys with me so far? What's the X value? Let's choose 3 again. Let's choose 3. So now, if you have an old calculator, it doesn't have that nice menu. I'm going to press paste here. But on the old calculator, when you choose it, it just takes you here. It puts in open parentheses, and you'd actually have to type 7, 0.35, 3. Okay? But this is what we want to compute. Are you ready? I hit enter, and what does it tell me? It sure does. In other words, what did it do? Yeah. Cumulative. Here, guys, I want to write down, right? It computed this in one step. Isn't that kind of nice? Yeah. So let's really understand what it did, all right? When you do binomial CDF, let me write down exactly what we did, because this is important, I think, for a time saver. 7, 0.35, what else did we type in? 3. What this gave me the probability of X being less than or equal to 3. That's what we computed, and that was, we said, 80%. And so, of course, that's not what we wanted, right? What we really wanted was the probability of X being greater than 3. And so that's going to equal 1 minus the probability that X is less than or equal to 3. So we do 1 minus the 80%, and that's how we do 20%, right? But I'll be honest with you guys, I think that this is the quickest approach we have. But I don't think you could actually understand it if you didn't first understand binomial PDF. So I thought it was important for us to do that.
So how do we calculate it? We have to use regular calculators.
Oh, yeah. Statisticians made a lot of money for their calculator work. You're right. I mean, think about it, guys. 100 years ago. 100 years ago. Not only did we not have the computers or calculators, I mean, you might have had, when did the first calculator get invented? Well, there's some real nice computing movies about World War II that are out recently. I don't know if any of you have seen any of them, but I think the one that's out right now, I still have to see the Hidden Figures. Anyone see that yet? I still have to see that. So, anyways, this is good stuff going on.
So which formula do you want us to use? Do you use either or?
Yeah, I'd like you to know how to do all of them, really, Sierra. I mean, but...
The second one is saying like everything.
Oh, yeah. Especially, I think the next question that we're going to be posed with, I think it's going to be our only choice. You'll see what I mean here, right? We're going to do this now. Say, suppose we survey 30 people. Is that better? Well, how do we solve this problem? It says, what is the probability that a majority of them support an issue? All right, guys, this is me doing my homework, right? You read some problem like that, and now you got to figure out, what do you write down on the paper? And sometimes it's like, well, I know he did it in class, but they didn't tell me what to do. Blank paper. So here's the first thing I would do. Let's write down what we're supposed to find in this problem. Find what? What? Well, first of all, isn't it true we're finding a probability? Find a probability that what? Who supports it? Doesn't say 30. A majority. All right, let me write that down. Find the probability that a majority support. That's what I need, right? So again, let's be very specific about what everything equals. Let X be the number of people that support the issue. Let's write down some other things that we know. The number of people that support the issue, if how many are surveyed? 30 are surveyed. That's different than last time. Last time it was 7. What is that 30 going to be this time for us, guys? That's our N. N is 30. That's good to understand. Now, some things didn't change, right? I mean, what didn't change? I guess little p didn't change. What's that still? Well, 35% were in favor, support, right? And Q is going to be 0.65. Okay? So now let's see. I wrote down find probability that majority support, but let's rewrite it now as what? We're going to say what it really says is find the probability that X is what? How do I express the majority this time? Greater than or equal to, what would be the majority out of 30? I guess 16, right? If you say 15, is that a majority? That's a tie. So let's do this. Let's say X greater than or equal to 16. Now, Sierra, this is where your question is really important, because when you said which of the two ways to do it, how did I do it the first time I did it? I divided it up into probability X is 16, probability X is 17. I'd have to go all the way up to where? And the answer is no thank you. No thanks. Right? I don't want to do that. Someone else do my homework for me. I've heard that enough this semester. No, I'm just kidding. So what do? Instead, I use the trick of complements. What's the opposite of X being bigger than or equal to 16? You could say that this probability is going to be 1 minus the probability that x is what? Less than or equal to 15. And so this is where I'm lucky, because I have a way of computing that. This equals 1 minus, what are we going to write down? Binomial what? CDF. And what are going to be the little things I need? Well, we have 30 trials, 0.35, and we're going up to 15. This will take care of the cases 0 through 15. It'll add up all those probabilities for me. Wow, I'm doing 16 statements in one. That's really nice. So let's work out what it equals, and let's be done with this. This is going to be 1 minus, maybe I'll pause. Well, should I do it? Yeah, I'll do this one, and then you guys will do the next one. Ready? So let's see. This one, well, I'll do it with you. You guys have your calculator? So how do we do this again? We go second distributions. Of course, the shortcut is second entry. We already did it. But yeah, let's go second distribution. Where do I go? Go up how far? That's choice B. Oops, I went too far. That's A. I've got to go back to B. Binomial CDF. And then it tells me, see, it saves all your, I love that it saves all my information, right? So I already have 7 trials. I have 0.35. What? Oh, wait, no, not 7 trials. What do we want?
30.
We want 30 trials. And we want x less than or equal to 15 is going to be the maximum x value. So that's what I'm going to paste into the main screen. 30, 0.35, 15, and they tell me, wow. So what's that? About, yeah, 0.9699, right? So almost 97%. So, but again, I write that down. Look what I'm doing, guys. The question was, find the probability that a majority support the issue. We're going to do 1 minus about 97%. We're going to get about 3%, right? You're going to get, actually you get 0.0301. So just over a 3% chance of my survey getting it wrong. That's interesting, right? If you only survey 7 people, there's a 20% chance your survey's wrong about what the state thinks. But if you survey 30 people, 30 is kind of a nice number. You only have a 3% chance of getting it wrong. Now, will that go down if we survey 300 people? A lot or a little? I don't know. Can you please figure that out for me? I want you to work with someone near you. Work with someone near you on this problem. And same exercise, but we're going to change the 30 to a 300. That changes a few things, right? There it is. If 300 people are surveyed, what's the probability? Remember how I started? I just wrote down what I'm trying to find. So I'm going to cover this up and go back to here and just pause and let you guys work a little bit. I'll walk around too. Let me just keep us moving here. If you do it correctly, here's what it would look like, okay? Basically, you have the same thing. What's the difference? Well, here, let me do it this way. Let me go to second distributions. So let me go to second distributions. It was binomial CDF. I always go too far. But this time, instead of 30, what does n equal? 300. P is still 0.35. What's the x value we end up doing? If you do 150, all right, that's kind of nice. Because if you do that, we get really 99%, right? More than 99%. So if you think about what I just did, I just computed if 300 are surveyed, right? The probability that X is bigger than or equal to, well, we want majority, so we want bigger than or equal to 151. That's 1 minus the probability that X is less than or equal to 150, right? And so that's 1 minus, you guys said 0.9999, right? So it's almost 0. That's interesting, right? So if you survey 300 people, actually, that's not only interesting, that's amazing. How many people we said live in the state? Millions. But if we have a binomial random variable, if we truly do, according to this, the chances of being wrong are almost 0. Now, wait a minute, because I just told you guys there's a talk, I think it's tomorrow, about how all the polls all over America got the presidential race wrong. Wow. Why is that? Well, there's a lot of reasons, and I'll know more after I hear the talk. But I will say this. It's not as simple as this example makes it out to be, because this example says binomial random variable, right? And we already mentioned, when you say, hey, are you in support of Trump, let's say, it's not yes or no. It's more complicated than a binomial random variable. If it were, you wouldn't have to survey too many to figure out what's going on. Okay? So part of the problem is that it's not a binomial random variable. Calvin actually mentioned, I don't know if you heard his answer, he said they surveyed the wrong people. Okay? We're going to talk a lot about surveying in chapter 1. How do you get a sample? I said 300 people are surveyed. How? Guys, if I walk around my suburb of Shaker Heights and survey 300 people, I will get a very different response than if I walk around my parents' suburb. They live out in Strongsville, Ohio. I mean, I'm telling you, you just look at the lawn signs. In mine, okay, we didn't have a Trump sign anywhere in my neighborhood. In my parents, that's all they had. Okay? It's very interesting. Ohio is an interesting state because we have a really nice mix of, we're the swing state, right? But so how do you get an accurate result? And that's some of the ideas that we're going to get into in chapter 1, which is really nice segue, I think, to what we're doing here. But I want to make sure you guys are comfortable with this before we do chapter 1. Sure, Sierra. I want to jump to the last section of chapter 4. This actually doesn't take long. We talk about mean, variance, and standard deviation for the binomial distribution. You guys have homework on this tonight, and you really don't need a whole lot of help here. Why? Because we've done all of it now. First of all, please understand, I just spent a long time on the binomial distribution, right? Yeah, both classes we spent a long time on it. But I wanted to make sure you have a solid understanding. And now what do they want me to do? They want me to find the mean and the variance and the standard deviation. We've done that before. What ends up being really nice, and if you guys were a bunch of math majors, I would prove for you. I would spend time and prove it because the mathematics is beautiful. But you prove that here are your formulas. Oh, no. These formulas we already had. These formulas are from section 2. No, what we would do is we would prove that there are really nice versions of these formulas if you know you have a binomial random variable. Check out how much simpler they get. Look at what the mean equals. N times P. The mean is n times p. And the variance, do you remember what the variance is? I didn't talk much about that. No? Do you remember what standard deviation is? It's a measure of, right, how far away from center we are, how spread out. Guys, the variance is the same thing. It's just that you're taking the standard deviation and doing what to it? Squaring it. And I guess, or you could do it, say the other way. What you do is you compute the variance, n times p times q, and then you take the square root, that gives you the standard deviation. Ready? So if you have that, let's use it in an example here. All right? Here we go. Suppose we know that the population proportion of left-handed students is 10%. I don't know if that's true, is it? Suppose we didn't say it's true. Maybe they made a nice number for me, 10%, right? Okay. By the way, how many people here are left-handed and willing to admit? Now, you rose your right hand, Brian. I don't believe. Oh, okay. 1, 2, 3. 3 out of how many? Out of, well, if you count me, I'm right-handed. 14. 3 out of 14. That's about 10%. Well, not. Well, it's a little higher than 10%, right? So we have a lot of lefties in our stats class. Okay. Anyways, that's not a random sample. That's a sample of people taking morning statistics. Right? By the way, this is another interesting thing. Throughout the years, in my upper level math classes, we would survey how many people are left-handed. Way above 10%. I mean, sometimes being right-handed, I was the minority in some classes. And they say that left-handed has to do with right-brained, and I don't know, something about it corresponds to people that like mathematics. So that's kind of interesting to me. Anyways, here's the question A. In a sample of 200 students, how many would we, there's the word again, expect. Expect to be left-handed. I mean, maybe you shouldn't expect anything, you just see what you get, right? But when we say expect, that has meaning in my class now, doesn't it? Right? So, again, maybe I'll make some notes here. So, for a binomial random variable, we have the following facts. We have the mean, mu, is equal to, do you remember the formula? I had it on the other screen. Yeah, I mean, that's a lot easier than having to do the thing where you add them all up, like we did for homework. And then the variance is just n times p times q, and the standard deviation is the square root of that. So these are just nice formulas, I guess. Okay, but in our problem we're doing, right, they say left-handed, okay? So let's suppose x counts the number of people that are left-handed. And what I'm saying here is x is binomial. And I'm saying little p is equal to what for this problem? Little p is a probability, right? What's the 200? That is important. 200 is going to be n. Okay, so you're right, that's an important number. I guess we're going to survey 200, right? N is 200. Little p is the probability of success, right? Yeah, they said 10%, right? So little p is going to be 10%, and once you have that, little q is going to be what? 90%. Okay? So question is, how many people would you expect to be left-handed? Part A. Well, remember that the expected value of x, that's the same as the mean. We said expected value. What's that mean? It means the mean. And so it's going to be n times p, which is, yeah, because it's 200 times what? 10%. Does that make sense to you? We would expect 20 people to be left-handed? Again, what I really mean is that's kind of an average. Guys, if you had 19 people left-handed, would you be surprised? Not really. Or if you had 21? Like in our class, when we had 3 people left-handed, I wasn't really that surprised. But if I said how many people are left-handed, and you all rose your hand, I would have said, wait a minute. I would have been so surprised, I would have said, you're lying. I wouldn't be that surprised if nobody did, because we only have 14 people in the class. Hey, what's the expected number of left-handed we expect in our class? Right? So let me do it in our class. Here, in our class, this is Martha's question, right? N is 14. So what's the expected value? Well, it's 14 times what? 10%, which is what? 1.4? That's okay. It's an average. So when Martha said, would I be surprised if there was nobody left-handed? I guess, to me, that's just as likely as there being 3, because you're that, right? You go down 1.5 or you go up 1.5. So it's kind of interesting. Here's part B of the question that we're asked, though. Let's take a look at it. It says, suppose you had 40 people out of 200. Would that be considered unusual? Well, what did we say the mean was? 20. So is 40 unusual? This is something I got at when we were talking about z-scores. Remember what a z-score is? It tells you how many standard deviations away you are. Now, I'm not going to do a z-score here, but I'm going to use some of the same ideas with you to answer question B. Okay? So, I guess what I want to do is I want to compute the standard deviation. Let's do that. I'm almost out of room, but I have just enough room to maybe finish it up here. So part B, let's compute sigma. That's the square root of n, p, q. And let me use my calculator for that one. So what do? We go to the calculator and we say, okay, square root. Second x squared will get me that. So there's the square root. And what do we want to type in here? 200 is n. Times what? Yeah, 10%, so 0.1. And then times again. Times what? 0.9. This is the standard deviation. 4.24. Right? So somehow, that's what I'm at here, right? Here, let me go here. I computed that this is 4.24. 4.24. And I guess the other fact we need is the following. More than 2 standard deviations away, that's considered unusual. So is considered unusual. kind of interesting. Calvin today was talking about 5%. 5% has a lot to do with this statement I just made right here. We'll get to that in chapter 6. More than 2 standard deviations. What do I mean by that? Well, the question that was asked said, right here, hey, if you had 40, would that be unusual? Well, here's how I would do this problem. I'd go back to my calculator, and I'd say, what was the mean again? We already computed it. 20, right? So if I do 20, and if I added some to that, how much? 2 times, well, 2 of these standard deviations. So I'll hit second answer, right? The negative sign. If I added 2 of these 4.24s, this should make sense to you. I'm going to be at 28.5, right? If you're farther than that away from the mean, it's unusual, right? I mean, the picture is, guys, 20 is the mean. That's the average, right? So 20 is the mean. And I'm farther this way. If I go past 28.4, which is 2 standard deviations, all this region over here is unusual. So yes, getting 40 left-handed out of 200, you'd say, hey, funny, something's in the water or something. Remember when I got hired here by our math department? They said, look out. They were naming the different faculty members. She has twins. He has triplets. He has twins. I already had 2 kids. I was like, okay. I've been okay so far. But they said, watch it. That's unusual. So anyway, it's kind of interesting.